All right, so you take a little break and come back. But here is the hands-on part that I'm going to, again, try to do live with you so that you can see everything as I do it. So I'm going to first just share my screen with you. Oops, step one. Okay, so hopefully this week your file folder, you made a new folder called week 2. And in week 2, you downloaded our week2.csv file. And also this OT699 week 2 completed file. I'm going to go through this, but I'm going to show you a few ways so that you can also type the code, because I think typing in the code is really important for you to really understand what we're doing. It's just that this week we had so many commands that I wanted to make sure we went through and in this logical order that I made this file so that you can see it and you can also step through these commands with me if that's easier. Like I said earlier, the CSV files look like this. They can be opened by Excel, but they essentially are just, I mean, they look like a normal Excel file. The difference is that the way that they're coded, so let's say don't save, the way that they are encoded would also let you open them in something else like a text editor or a program editor. And when you open it like that, you remove all the fluff that's embedded in a normal Excel file. That makes it a little bit easier to look at. Oh no. Let me just open it with text edit. And it looks like this. So this is that exact same CSV file, but now you don't have that nice column formatting. You don't have all those extra buttons. It's literally values separated by a comma. So the comma denotes the column essentially. But as you can see, sending you this would be so much more difficult for you to read than just sending it to you as an Excel file. So that's kind of the difference. Okay, so I also said that this week I will go through, so let me minimize this, how to use the command line. So I'm on a Mac, but if you're on a Windows computer, it should be relatively similar. On a Mac, you're gonna go up to this little search icon, click on that, and then I'm gonna type in terminal, and you should see this app terminal come up. So the kind is application, it is a terminal. You can click it and double click and it will open. So this is my terminal. Similar to other command lines, you can type commands here and it will do it. But this language that it's running is Bash. So it's a Linux language and it's just, it has different syntax and everything. So we're not going to do a whole lot here. I will, however, just tell you, you can type Jupyter Notebook here and press enter. And what it will do is open your Jupyter Notebook. Okay, so I'm going to close this and I'm going to actually close this and you can just click terminate. I'm going to show you the other way we did it last time is we also could just go to Anaconda Navigator and open this, which is an app. It's loading. And then in here, we could go to Jupyter Notebook and click launch. And actually, we'll open that terminal too. Maybe you noticed that last time, but it's like another step to do it. So either way you decide to do it is fine. If you're on a Windows computer, let me just show you. Well, obviously this isn't a Windows computer, so I can't show you exactly what it would look like, but essentially on a Windows computer, usually in this lower left-hand corner, you have that Windows icon and a little search bar. And there you're gonna type Anaconda prompt, and it will bring up a window that essentially looks like this type of window. The blinking cursor tells you where to type, so you click on it, and then you type in Jupyter Notebook, and you can open a notebook. Okay. All right, so now we're gonna go to our file system. So we're going to our class, OT699. Like I said, hopefully you have the week 2 folder in here. You have this week2.csv. You also have the completed one. But in your case, what I'd like everybody to do is go over here to new and click Python3 and open a new notebook. And we are going to call this notebook I think it's just OT699 underscore week 2 and rename. All right, so if we go back to this browser, which has our all the files that are in this folder, now we have a new one, OT week 2 IPy notebook. Okay, so what I'd like for you to do, ideally, is for you to type in the commands as you see me go through them. what I'm going to do is open this completed notebook because I've already typed in a ton of commands that we're going to go through today. But so for instance, instead of you just opening this notebook like me and just running them, I would prefer it if in yours you went ahead and did 5 minus 5 and ran it like that, for instance. I just think that's a better way for you to do it, but I am including this one so that if you have any problems or if you did something, let's say you did like that and ran it and got an error, then you could look at this and say like, why does mine not work? And then go back to this one that's the correct one that we know should work and figure it out from there. Okay, so I'm gonna go and step through this. Again, just as a refresher to Jupyter Notebook, you can do things to run the cell. On my Mac, at least, you press Shift and Enter and it will run that cell, or I can just click Run and it will run the cell. If, for instance, you have some output here already for some reason, you shouldn't, but if you did, you could go to Kernel and click on Restart and Clear Output, and that will clear all any cells or output that have already been run. Okay. The last thing that I wanted to teach you about Jupyter Notebook, and one of the reasons I also like it, especially for teaching, is because you can have within a cell different types of code that you put in. So right now it's highlighted in green, which means that I can edit this cell. And this type of cell input is code. But up here, you'll see I put this heading. And actually, if I click it, it's green. I double clicked it. Then it looks like this. And it's because I had changed it from code, which it originally was, to Markdown, which is a language for like annotating your code, essentially. And the hash gives it different types of heading sizes. So one hash is the main heading, so that's why it looks like this. And if I run it, it looks big. If I double click it again, then I could type 2 and run, and it'll be a little bit smaller, and 3 and 4. It just kind of gets smaller as you add hashes to it. But anyway, so that's what I did to get these lines. So if you wanted to, in your notebook, I'm going to press Escape, which turns this cell blue, which means I can't edit it, but I can press D twice and it will delete the cell. And I'm going to change this. So if you wanted to do this from your own, actually, let me just delete this. I would click here. I would change this to Markdown. Then I would type hash data types and then run. Or you could type hash, 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 change it to Markdown and type this is a heading and then run. Okay, so that's how we get the headings, just in case you're curious. All right, so stepping through, we talked first about data types in the lecture. So as we said, you can do integers and you can do basic math with them. So things like subtraction makes sense. You can also, however, if it's a string, which is denoted by these quotation marks, like here it's string 5 minus string 5. The string type doesn't have a subtraction option with it because it doesn't really make that much sense. So if I try to run it, I will get this error. And the type error is, it is a type error because it's related to the data type. And it's an unsupported operation for type string and string, meaning that you cannot use a subtraction for 2 strings. However, you can use an addition for 2 strings. So if I did 5 plus 5, because they are in this format, it will just concatenate them together. So it might be easier to see it as this, where it's hi plus by, and it just concatenates it into one word. Or the kind of like we talked about before, I can also add a space here, and it will be one word. So play around with these things. Some things that you might want to try are, for instance, like you could try adding a number plus a word, and it will still concatenate it. But if you do a subtraction here, it will give you an error. And if you, for instance, do like a division, you'll get the same type of error, but it's like this now. You could also try it between 2 data types. So if you did a number or an integer divided by a string, then what you expect is the same error, but it'll say for int and string. And that's exactly what you get. Okay, so I'm going to just put this back to what it was so that you guys have it. Okay. For variables, which we also talked about last week, we did this variable. So we assign a variable my name equals this string Lee. Obviously, you should replace this with whatever your name is. So Bob or Billy or whatever. But you would put your name here. And one thing to note, like we talked about before, is that strings have these quotations. It can, in Python, it's flexible, so it could either be double quotes or you could use single quotes like that. Okay. It doesn't matter, but you do need the quotes so that it knows that it is a string. Whereas the variable itself does not need a string because it's being read as a variable. So if I run this, then we say print this string plus my name plus exclamation point, then we have hello world, this is Lee, and this is the variable that got substituted in. Okay, one thing that you could try here is if you don't include the quotations, what happens? So think about that. Guess what you would think would happen? So what's going to happen is the computer is going to read my name equals Lee. And because it's not in quotes, it's going to think Lee must also be a variable. However, we've never defined Lee as a variable and we didn't give it any value. So I think it should throw us an error. So if we run it, it says exactly name error. The name Lee is not defined. So that is just something you can play around with to see how things work. Okay. Another example that we went over in class is to say, for instance, assign integer values to different variables. So x equals 5 and y equals 4. And when you run it, nothing happens. But if you don't run it, then when you run this, it will give you an error because you hadn't defined x and y. So that's 9. This is just an example to show you that you could put these in different cells, like here and then a separate line here, or you could just put them all into one and it's also fine. Okay. The next thing that we'll go over are Booleans and conditionals. So for instance, let's set the variable a to 5 and b also to 5. And we talked about this, which hopefully you remember, 2 equal signs means equals. All right, so here, if I run it and assign these variables, now I run a equals b, then the output is true. So that's the output of a Boolean. I can also assign a variable. So my bool variable equals a equals b. And if I run that, and then I try to, so that the reason you don't see anything come out is that it gets stored in this variable. But then if I type this variable, then it will give you the same answer. Okay, so you can try all of these. So this one, a exclamation point equals b should mean a does not equal b. And so that would be false because here we had a equals 5 and b equals 5. But if we were to go up here and change these definitions, so a equals 4 and b equals 4, remember we have to run this so that the computer has that input. Then we jump down here and we run this. Now it's true because they aren't equal. There's also the less than or equal to, greater than, and greater than or equal to. So try playing around with different values for these numbers, and then try these different combinations and conditional statements. Okay, the next part is what we call conditional statements. So one thing I want to introduce you to as well is comments in Python. So most of the time we just type the code and it goes straight to the computer and the computer executes it. However, we can type comments because these are to ourselves, like notes to ourselves. And the way that we differentiate a statement to the computer versus a comment to ourselves is just with a hashtag here. So this is a comment, you could put spaces, you can put whatever you want after this hashtag. The only difference is that you have to make sure that it's code, and that is what is different about these different cell types is like the hashtag in a code cell will be a comment, but if I change this cell to a markdown, it becomes a heading. So just make sure that this is on the code setting. But this is a comment. I put a comment on if then statements, and then I also put a heading for it. So sometimes when I'm writing code, especially once it starts to get long, I'll put little comments for what I'm doing and why. I almost only use these like markdown headers when I'm teaching so that it's easier for you to read, just because it's bold and it makes more sense that way. Okay, so now we're going into if-then statements. So if-then, so let's set A and B equal to 5 again. And the first one is an if statement. So actually, let me run that. Now, if A equals B, print they are equal. So what do you think should happen if we run this statement now? Hopefully you said that the computer will output they are equal. We run it, and it's true because they are equal. But let's go back up here and set A equals to 4 again, and we have to run that. And now we'll do it again, and this time nothing should happen. So it ran, and you know that it ran because it has a little number that's completed. And now it ran again. That's like the 33rd command that it's run. But essentially, even though it runs, there's nothing for it to do because this statement was not true and there's nothing else. However, this statement should be true because if A does not equal B, print they are not equal. And now they aren't equal. I'm going to set this back to 5 so that we can keep going. So nothing happens there. In this case, A equals 33 and B equals 200. If B is greater than A, print B is greater than A. So that's true. Here we set A and B both to 33, but we have the if and the elif statement. So actually, I'm going to type this over in our other notebook so you can see what it looks like. I'm going to try to remember it. Just because of the tabs, which are important. So let's say, what do we say? A equals 33 and B equals 33. And then we're going to say if A, what did we say? Oh, if B is greater than A. Okay, if B is greater than A, colon, remember that's very important. And actually what you'll notice is if I do a colon, if I have if and a colon and press enter, it will auto tab because it knows that it has to tab because that's part of the syntax for Python. So I'm going to say print B is greater than A. Then I'm going to do a backspace and put elif or else if A equals B, colon, and again, it will auto tab print they are equal. Okay. And then I run that and it says they are equal because that's the condition. But if I made this A bigger, then it wouldn't satisfy this condition or this condition and nothing would happen. And if I made B bigger, then it would satisfy this condition and this should happen. Okay. So I'm going to delete this. I mean, it doesn't matter because I'm not going to give you this anyways because you made it yourself. But I wanted to show you me live typing it so you could see what it looks like. Okay. So let's go back here. We'll run this code, A and B are equal. This is an example where nothing happens, or where, sorry, B is greater than A. So this should happen. This is the example where we switch it. And in this case, A is greater than B, but that doesn't meet this condition or this condition, so nothing should happen. And if you run it, nothing happens. This is one where we've added the else condition. So remember, else is like a catch-all. So here, it doesn't satisfy this condition. It doesn't satisfy this condition, but it should fall into this else category. So we should say A is greater than B come out, and that's what happens. And here, we just simplify it to if and else. So let's say we only care if B is greater than A, and otherwise we don't care. So that's what happens. So take some time, go through these, type them for yourself, play around with the values of A and B. You can play around with what gets printed out too, or what gets done. But yeah, just get familiar with this type of logic. All right. The next type of logic is what we call for and while loops. So the easiest example is to say for x in banana. And what that's going to do is assign this variable x to each letter in banana one by one. And then we'll say print x. And I'm going to type it out. Oops. I'm going to type it over here for you. And let me just restart. oh, not run all. I want to restart and clear output so there's nothing there. Okay, so I'm going to say for x in, let's say USCOT is the best, and put the colon. I'm going to say print x. All right, so let's run it. And what it did is super fast. It printed out each letter in this phrase. Okay. So similarly for this, it will print out for each letter of banana. It actually is looping through, and this computer is doing it one letter at a time, but this is such a simple command, and the computer processing is so fast that it looks like it prints it all out at once. You can also do for x in a series of numbers. So let's say I wanted for x in all of these numbers and print out x. So it'll happen like that. I could also modify this. So I'm actually going to copy this and put it over here. It's something that we try. Nothing. Okay. So let's say for 0, 1, 2, 3, 4, and let's say I want to print hi for as many times as there are these numbers. Or we could say, hi, this is round, and then a space, and then we'll say x. All right. Oh no. Oh, that's right. So this is a great example of live coding and what an error looks like. This again is a type error. So I can only concatenate strings and not integers. And in this case, because x is assigned to each of these values and each of these values is an integer, it won't let me do it. One thing that I'll show you is I believe there's a command where we can force the integer to become a string just by typing string around x. So let's see if this works. Yeah. So essentially what it did is it forced x, which was an integer, to be a string so that we could execute this command. That's a little more complicated. You don't really need to know that, but that's just like what some troubleshooting looks like. But I only knew that, and if I didn't know that, I could say, let's say I didn't know that, then I would have just done this and come to Google and said Python and put quotes around this error. How to resolve type error, can only concatenate string. And then this is what Stack Overflow looks like. It's just a million posts like this. So they usually will say, I tried to do this, how do I do it? And I want to have this message where the input is this, and then I want to put the input together, and this is the error, and these are my updated code. And then down here are answers that get upvoted, kind of like on Reddit, so that hopefully the first thing you read is the best answer to the community. And in this, they did exactly what I did. So to solve the issue, just add string to your number or value like this. And in this case, string like str parentheses is actually a function that converts a number into a string or forces it into a string. Okay, that was a tangent. Let's go back. So you can play around with for loops as well. I also showed you a while loop in the lab or in the lecture. So here we again have to initialize the variable x. So we'll say x equals 1. Then we'll say while x is less than 10, print x. And then we increment x so that each round that it goes through, x is going to equal first 1. It'll print 1. And then it's going to say x equals x, which currently is 1 plus 1. So now x is equal 2. On the next round, it'll go through and say, while x is less than 10, which is while 2 is less than 10, print 2, and then x equals 2 plus 1, which is 3, and so on. So what it should do is print out 1 through 9, and then stop, because after 9, it'll become 10, and then 10 is not less than 10, and it will exit this loop. And that's what it does. Here's some errors that can happen though. So for instance, you could forget to, let's say I wanted to do this exact same thing again, but I forget to reinitialize x to 1. So now it's going to start at whatever the value of x is. So if I run this, nothing happens because it doesn't know that x is a different value. And actually, if I put a cell above here, so let's say insert cell above, and I say print x, it tells me that x is 10. So this is how I can check what's gone wrong and troubleshoot. And then I'll be like, oh, I forgot to reset x. Okay. This one, don't run it. It will make you restart your computer. But this is an example where if you don't, let's say I reinitialized x equals 1. All right, so let's delete that. I don't need that anymore. We'll just do x equals 1. If I do it this way, what's going to happen is it's going to say, while 1 is less than 10, print 1. And it's going to print 1 for eternity, and there's no way to stop it. I will show you what it looks like, but I won't recommend that you do it in case your computer has another reaction that I don't know how to troubleshoot for you. So if you do this, like I said, it's just going to be an endless number of 1s. So if I run this, it's endless number of 1s. And as you can see from this scroll bar, it's going for forever, and my computer is about to get really mad at me. This is an asterisk because it's continuing to go. So what you have to do is go kernel interrupt. Whew, I think it should be done now. I'm going to say, let's restart and clear output. And what that will do is just restart this instance. It's like I closed the program and opened it again, essentially. Okay, but you'll see it cleared all the numbers and everything's started over. So now I can go back and rerun these, and it'll give you the same things again. This is a pretty much more advanced lecture, I think, than last time. So if you have any questions, let me know and we can talk about it again in the lecture, but I wouldn't worry too much right now because a lot of this is just to get you familiar with what's going on. All right, functions. So one of the functions we talked about was the range function. I just want you to test it out here. So if you put range 6, it will tell you what it's going to do, and it's going to give you a range from the default value of 0 until your stop value that you gave it of 6. So if I say x equals range 6, that's going to assign this variable to x, and I'm going to insert a cell below. You shouldn't have to do this because I'm going to give you this code, but it's going to be print x, so you can see what x is. Okay, well, that's very simplistic. So if I now say for n in x, print n, it's going to give you a value for each of the numbers in this range from 0 to 6. And that will give you 0 through 5. And x, because we set x to range 6, this will give you the exact same thing. We just substituted out range 6 for x. And then there's other options where you can step through. So for instance, you could put a starting value of 2 and it'll go 2 up to 6. This is the step of 2 as well. So it'll just give you 2 and 4. So play with this. You can make it like 600 and then you'll see like a whole lot more numbers, etc. Okay. And there is an undo. So just like normal, you can just do undo, Control Z, if you did something then you didn't mean to. All right, so now we're going to move on to modules, packages, and libraries. So here, like I said before, there are some commands that we need from some packages and libraries. What I'm going to do first actually is run this cell, which is a OS from this package, get CWD. This is a function that, again, this command from the OS library will get the current working directory. But I'm going to do it before I import it to show you what error you'll get. So if you do this, it'll say name OS is not defined because it doesn't know what OS is, because what you have to do is you have to import OS first into here so that it has all these functions. So now we're going to run this, and now we'll run this, and it will give you back your file pathway. Okay, and I did put a note here for you too. This should run for you, but sometimes you have to install the library first, like we talked about. So for instance, if it says pandas is not available or gives you an error, then you can try this line of code, just conda install pandas, and it should install it for you. Okay. Next, reading and writing files. So remember, we have this file here, which is that CSV that we opened, which looks like this. Okay, so we're going to read it into this computer program as a variable. So the file name, we're going to assign a file name variable, and that's equal to week 2. We're going to say pd.read_csv. So this is the library and the function to read a CSV in, and this is the file name. So we're going to read this in. So let's run this and run this. And what you should see is this is all that data that was in that file, but it's abridged in the middle, and it will tell you the size. So it's 458 rows and 9 columns. Okay. Now what you really usually want to do is read it in as a variable, so as a data frame variable. So I'm going to say my df, which is my data frame, is equal to pd.read_csv file name, and press run. And now we can manipulate the data. So we'll take this variable that is essentially equal to this whole thing. And if we do .head, head will give you the heading or the first however many lines you put in here. So let's say I just want to look at the first 5 rows of data and see what the data format is. And it will show me the first 5 lines. Alternatively, I can put, let's look at the first 50 lines, and it will show me the first 50 lines of data. Remember again that because Python is 0 indexed, your first line is indexed here as 0, and it will go to 49, but there are 50 lines in total. Let me go back to 5 just because it's easier to see. And then we can do things with this data set. So for instance, we could get what's the average age? So this is some sort of data set about sports players and things like that that I got from the internet. I want to know the average age. So I can use this function called mean, which is average, for this column age in this data frame. And it tells me right away. So this is, I think, a little bit faster and easier than what you might have to do if you were working with an Excel sheet. Similarly, you can do things to the columns. So let's say that right now the weight is here in pounds, but let's say I needed the weight in kilograms. And one way I could do it is to open up this file and multiply each of these values by the conversion rate, which is 1 pound is 0.45 kilograms. But in Python, what I can do is just say a new column. So I'm going to call this new column weight underscore kilogram. And I'm going to assign it to the value from this weight column times 0.45. So it's this conversion. And if I run it, and then I look at the data again, what you'll see is now there's the weight column, but there's a new column that I made called weight underscore kilogram. And this is everybody's weight in kilograms. So it's a very simplistic view, but it makes things easier. And you can imagine doing this on a large scale with millions of data points. Finally, the last thing I'll do is take this data frame that now has this new weight kilogram column, and I'll say to CSV, which means save it to a CSV called week 2 updated. I'm going to click run. And what you should see over here is you now have a new file, week 2 updated. And if I go back to my file folder, it's here, and I can open it, and it should have this extra column called weight kilogram that I created. Okay. The last thing that we'd like you to do is to write your own function. Okay, so first, like we talked about, these are the components you need to write a function. So you're always going to type def, because that tells the computer you're writing a function, and this is the definition of your function. Then you're going to give your function a name. In this case, I gave it the name myfunc. And then you're going to put whatever the input arguments are. So this time it's going to take in a variable x. And this is what I want it to do. So I'm going to assign another variable y equal to x plus 10. That means that whatever number I give it, my function is going to add 10 to it. Then it's going to print it out, and then it's going to return this new value. So if I run this, and I say a equals myfunc, and I give it the value of 1, what do you think will happen? So hopefully what you're thinking is this value 1 will go in here for x, y will equal to 1 plus 10. It'll print 1 plus 10, which is 11, and then it'll return the value of 11. So let's try. And that's what happens. Also, because I assigned a to the output of this function, a will also equal 11 now. Okay, and you don't always have to put a return on it if you don't need it to return a value. So this would run just as well. And if I add a cell below, then I could say like myfunc 10, and it will give me 20, for instance. So your assignment this week to try to start thinking about things in all of those steps we just did is to write your own function that will tell you or output true or false if the number you give it is greater than or equal to 10 or not. So think about this in the context of all the commands. You can go back and copy paste things. You can copy this basic syntax for a function, etc. Then I want you to write 3 test cases for how you would test this out. How can you make sure that your function correctly gives you true or false based on this condition of if it's greater than or equal to 10? Okay, so hopefully you'll get thinking about this. You can send us messages if you have questions, and we'll also go through this in class together. All right, thanks a lot. Hope you have fun this week, and we'll see you on Thursday.